How does Java's Throwable class create stack traces? Imagine trying to trace a path back to where a problem started in your code. When an error happens in Java, understanding that path is essential. The Throwable class is at the heart of this process. It captures a snapshot of the call stack at the moment it is created. This snapshot is what we call a stack trace, and it shows the sequence of method calls that led to the creation of the throwable object. When you create an exception or error in Java, the runtime immediately records the current call stack. This is done by capturing the active method calls at that precise moment. The stack trace is stored as an array of objects called StackTraceElement. Each of these objects contains details like the class name, method name, source file, and line number where the call occurred. The order of these elements starts from the most recent call, which is at index 0, and goes back to the earliest call, often the main method or program entry point. This order helps you see the flow of execution leading up to the problem. You can access the stack trace programmatically using the getStackTrace method. This returns the array of StackTraceElement objects, letting you inspect each step in the call sequence. Alternatively, you can print the entire trace with printStackTrace, which outputs a readable list of method calls and line numbers. When debugging, this trace is your map to find where the error originated and how it spread through your code. It shows exactly which methods were called and in what order. The stack trace reflects the point where the throwable was created, not necessarily where it was thrown or caught. This means if you create a throwable early but throw it later, the trace still shows the creation point. You can also modify or clear the stack trace, but doing so does not change the internal data stored in the throwable object. This preserves the accuracy of the debugging information. To use this information effectively, always check the top of the stack trace first, as it shows where the throwable was created. Then, follow the sequence down to see how the error propagated through your code. The file names and line numbers in each stack trace element help you jump directly to the problematic code in your development environment. By understanding how Java's Throwable class creates and manages stack traces, you gain a powerful tool for fixing bugs faster. It allows you to see the exact path your program took to reach an error, making debugging more straightforward and efficient.